When balancing an equation, I find it easiest if you list all the elements under the reaction arrow and then go ahead and put a spot to tally how many of each on either side of the reaction arrow. So on the reactant side, we have 1 potassium, 1 chlorine, but 3 oxygens. That's what this subscript of 3 is telling us. It's only on the oxygen. There aren't any parentheses that you need to distribute through. On the product side, we have 1 potassium, 1 chlorine, and 2 oxygen. So it doesn't currently balance. So one of the things I have found helps a lot is if you have an odd number. This could never be odd because the subscript is even. It can never be odd, but we can make an odd number even by doubling it. So that's a lot of times where I start in attempting to balance an equation. So if I put a weird looking 2 out front of that, now I have 2 potassiums, 2 chlorines, and then remember you're saying 2 of this whole thing, so in each of them there are 3 oxygens, so since there's 2 of those, we have a total of 6. So now every number is wrong instead of just oxygen, but we're going to attempt to fix that now. Now that we have 6 oxygens on the reactant side, we need to put a 3 out front of the oxygen on the product side in order to make that 6. So now our oxygens work, and the only thing that isn't working now is potassium and chlorine. So we're going to go ahead and fix that by putting a 2 here, and now all of our atoms balance. We have now followed the law of conservation of mass. Then what they're going to ask on the Regents exam most likely is either for a specific coefficient, so they may say when the reaction is balanced using lowest whole number coefficients, what is the coefficient on KCl? Or what they may do is ask you to come up with the sum of the coefficients. So when we add this up, we have 2 for the KClO3, 2 on the KCl, and 3 on the oxygen, for a total of 7.